So this is the part 2 of the law of sines that we did way back on Monday or Tuesday. Or on Monday, actually, it was. And on Monday, you looked at just certain cases, and that was when they involved particular problems. Mainly, they had two angles in them, right? So if you had an angle side angle or angle side, you use law of sines. You got one answer and didn't have to worry about anything. If you might remember, with law of cosines, we did side 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 and side angle side. And back in geometry, those were the 4 triangle congruence theorems that existed, right? There's 4 of them. Now, but there's another case where you can use the law of sines, and that's for side side angle, or some people prefer angle side side, right? So this was never a triangle congruence theorem for a particular reason, and that's because in certain circumstances you could have 2 solutions, or you could have 1 solution, or you could have no solution, right? So today's focus strictly on side angle, side angle, right? And why it's different, right? And mainly the most intriguing part comes when you have 2 solutions. So let me just look at that one particular part. So what happens here when you have 2 solutions? So if you're given, like, let's say this is diagram. Let's say this is 50. Right? And let's say this whole side is 10. Right? And the question is, what is the length? Actually, I gotta draw a better better triangle than that. More of an angle. There we go. Let's say that's 50. Okay. There we go. And that's 10. Sometimes if we say, like, well, A, let's say this is A, and we have this dotted, another value for this side A, right? And there is a circumstance where if side A equals, let's say, 11, right? Or actually, better yet, 12. So it's a little bit longer than side B, right? Just a little bit. Well, this 12 could be drawn 2 ways. You could say, well, from here to here, right? That could be 12, right? But I could also draw a leg of 12 right here. And what you end up with is 2 different possible triangles, right? We could have this first one, which right here as a possible answer, and then you could also have this bigger one as a possible answer because they fit the criteria, right? They have the side angle of 50, this side is 10, and they have another side of 12. It's just geometrically that 12 could be drawn in 2 places. So all the information is accurate. It's just 2 ways of doing it. And that's why back in geometry, this was not a triangle congruence theorem, because there was more than one way. And we can't, if you guys remember what functions are, you need to have, one answer here, right? We can't be just getting 2 different answers. And anybody can pick, well, I chose this method, I chose that method, we got different answers, right? So that's why this was never a triangle congruence theorem. It's for that reason. So the focus of today is that how do you find both answers and then find all the missing values for both triangles, right? So if I broke this up into 2 separate triangles, right, you would be able to give me the information for this triangle. That's 10 and that's 50, right? And that's 12 for that one. And then there's also the bigger one where that's still 50 and that's still 10, but the other leg is over here, and that's 12, right? So find all the information for both of them, right? Now they have a lot of things in common, which is nice. It's going to be a lot of supplementary stuff. So basically you're going to have to find this angle, right, for here to find that triangle, and then you're going to have to find this angle for that triangle. And it turns out that these 2, call that B2 and this one called B1, angle B first one, angle B for the second triangle. Both of those, the first angle B and the second angle B, add up to, no surprise, 180 degrees. So if you find one of them, you can automatically find the other just by subtracting. But the thing is, you need to know how to know to be doing this in the first place. So how do you know it's two solutions and that you need to, do all this process? All right. So in short, this happens. Two solutions happen when this value, this 12 I just picked out, right? It's somewhere between the height of the triangle. If I drew a height here, it's a little bit bigger than the height, right? Because if it's smaller than the height, then there's no triangle. But if it's the same as the height of the triangle, a little bit bigger than the height of the triangle, but smaller than this diagonal, that's when you get the two solution thing going on. Okay, so this is side B because this is angle B. So basically, this only happens if A is somewhere between this side and the height of the triangle. The H is the height of the triangle. Actually, let me write that the other way. H is smaller, so it's going to be H. Sorry about that. There we go. The height of the triangle, this new value of A, 12 in this case, is somewhere between these two numbers. And this could be like a, H could be like a, I think on this one it comes out to like 8.9, and the B happens to be 10. So there's only a few numbers, like it has between 8.9 and 10 for this whole thing to happen. So the two solution thing doesn't happen with like a lot of different numbers. It's just a small, tiny pocket, right? So that's how the two solutions come up, and again, that's why we don't have a congruence theorem for this particular situation. Now, for side-side angle, it's possible to get one solution just like all the others, okay? And that's the case where this, on this one, that this value of A that we're looking at turns out to be the same as H, right? So if this happens to be, the actual leg turns out to be the height of the triangle, then there's one solution. So that's one possibility. Alright, so we got A, again 50, I'll call this 8, and then A and H happen to be the same thing. Okay, if H would make this a right triangle, by the way. So if the values they give you happen to make it a right triangle, yeah, then there's one solution. Doesn't happen very often, but that's the one particular situation where it does. And the other one is that we'll do here, yeah, back to 50, and let's say this is 10 again. The other one is, okay, this is the A equals H. The other one is if the A value is just bigger than this B value. So if A is bigger than B, so it's longer than this, then you get one solution as well. And it's not particularly important that you memorize and know this exactly, but just trying to help you understand the geometry of it. Like we can get out a compass and actually measure these and show why it has to be a one solution or two solutions and whatnot. Maybe if you have time, we'll go back and do that. And the last one we'll look at is when you have no solution. So let's say, lastly, that's 50, and this is 10. And what if I say the A value equals like 4? Right? There's no way, if this right here is 10, and this is a 50-degree angle, a length of 4 will just never connect to make a triangle. So a no solution means the triangle inequality doesn't work, and it's physically impossible to draw a triangle with those lengths of sides. Right? So it does not exist. Can't quite reach. And in this case, it's when A is smaller than the height of the triangle. Right? It's impossible to make an actual triangle. The height is, this height right here is the shortest length of a triangle. So if the leg comes out shorter than the shortest length of a triangle, it's impossible to actually draw that triangle. And we got some steps down here that kind of break it down mathematically. So this is the more geometry part of it, like visually seeing why there's no solution, can't physically draw it, why there's only, when there's only one solution, right? The value is the same as the height, or the value is bigger than this length here. And when we have two solutions where that value of A is somewhere between the smallest value and that length of the diagonal. So let's just look at each one of these now mathematically, and it gives all the steps here. Basically, let's start with the first case. How do you get no solution? How do you know? Basically, if you just do the law of sines and you get an error, like you'll find out the number is bigger than 1, sine can only be between -1 and 1. So if you do a bunch of calculations and you get an error, that means no solution. So you just use your calculator like normal, and if it comes up an error, that means there's no solution, and you don't have to really worry about it. So that's kind of what this first one is, just to draw it out. Here, sketch these out. So there we go. So, and as usual, it's good to draw these at first, especially just to make sense out of what you're doing. All right. And our question is basically, let's see, we got 5 here, right? And we know angle B, which should be right around here. Don't know what that is, but we know the length across from it is 10. Remember, these are always opposite of their angles. The little b's and big B's, little a's and big A's are always opposite. They don't actually touch. So once you see this, when you have a side and an angle opposite of each other, that was the cue to use law of sines, if you recall. Like, how do you know when to use it? When you have these things opposite. So we were able to do that by saying the sine of 42 divided by its opposite side, right? Sine of A over A, and it will equal the sine of B, that we don't know, over 10. And we did a little algebra and solved that. So we know the measurement of angle B would equal, and you might recall we kind of took some shortcuts. If you know how to do those, that's fine. If not, you can show all the little algebra. That's fine as well. So obviously, to get the answer, if our answer is an angle, we got to use arc sine, right? So that's the first thing to remember. Answer is an angle, you got to have this button, right? If our answer is a side, that's when you just use regular sine. And the diagonal is what goes on top. So 10 times sine 42. And then the remaining part, that's what you divide by 5. And that's what goes in the calculator. Okay, and if you punch it in with me, let's find your arc sine button. If you have a fraction button, use that too. On this one, you just press the sine button twice. Changes to arc sine. Use the fraction button right below it, and then punch it in. Okay. Hit enter, and it says domain. Right? Domain issue, which we talked a little bit about. Okay. And if I go back, I say domain issue, what does that actually mean? Well, if I delete this, if I just take off the arc cosine, I look at what this number is, this decimal, you can see it comes out to something bigger than 1, 1.33. That's why you can't take the arc sine of it, because sine only exists on a unit circle, the lowest at 3 pi over 2 or negative pi over 2. The lowest number the y coordinate could be would be -1. And then pi over 2, the biggest rise value on a unit circle, which means 1, is +1, right? So it's impossible to have an angle that has a 1.33. That just doesn't make sense to have a 1 point anything on a 1 unit circle, right? The answer doesn't go above 1 or below -1. So just to understand why that happens. So we get error, no solution. And different calculators will say different things, so that's why it's good to know what it looks like on your calculator, that you're familiar with it. So if it happens, you're like, did I type something in wrong? Am I not using this right? And you know, because some people grab a calculator, oh, I forgot mine. They grab one of these, they're like, I don't know if I know how to use this. Maybe I messed up and it's just not calculating properly, and now you're all worried about if your tool's correct or not, as opposed to focusing on the work. So, but that's what happens when you got no solution. Okay. All right. Any clarification needed there? It's kind of, you know, pretty straightforward. Okay. But just in case. All right. Lastly, we have 1 solutions and 2 solutions, and there's a little bit of directions here. Yeah, a little bit of directions. And they say what you're going to do is, if you don't get a no solution and you're dealing with a side-side angle, right? Every time you're dealing with a side-side angle, you have to go through this process. So the number one thing after all the algebra's out of the way is, how do I know when to do what? So you got to know the cues, right? The cue for this is, again, it's side-side angle, right? And then when you actually get an answer, then we have to take that answer, we have to test it, we have to put in this little formula, and if the answer comes out bigger than 180, we know there's 1 solution. If the answer is less than 180, we know we have 2 solutions. Right. So you're always going to do the first step the exact same way, right? Error, you're done, you know, fastest possibility. And then here we're just going to repeat it. Say that's 41. And again, this is A, this is B, this is C, and this time, let's label all this. Question, if this is 15, right, does it actually reach all the way? We'll see, right? And if C over here is 13. So once again, use the diagonal they have a value for, it's A. So we can do the same first step as we just did, this law of sines, right? So sine of, what was it, 41? Over 15 equals sine of C over 13. So do the work, and I think the C comes out to, I can't remember it, dang it. It's going to be the arc sine, let's see here, 13 times sine 41, all over 15. So we got to use the calculator. Arc sine, fraction button, or parentheses if you don't have the fraction button. 13 sine 41 all over 5. No, 15. 1, 5. All right, and that comes out to 34, let's say 0.7, just round it. All right, so we have a possible, correct angle, which means we just found out this right here could be 34.7, right? And it could be just this one triangle. The question is there another way to actually draw this triangle, and does this situation over here exist where it could be drawn 2 different ways, and we have to figure out if it can or cannot. And the way to do that is right here. You find the supplement of what we just found, right? Find the supplement of this angle and add it to the original angle we were given, 41. So I got to do 2 things, right? I got to first subtract this from 180, get the supplement, and then add 41 to it. And then I'm looking to see, is it bigger than 180 or less than 180? Right? That's the key. So if angle C is the angle I'm working with, find its supplement by subtracting from 180. So the supplement of angle C is going to equal 180 minus 37.4. Alright, so 180 minus 37.4. Got 142. Yours.
Is that supposed to be 34.7 instead of 37.4?
Of course. Is it Friday? Is it dyslexic day? Good eye. Alright, same problem though. Supplement will equal 180 minus 34.7. Thank you for not making me go all the way to the end to realize it. 34. Not everybody is so kind. So we got 145.3. Okay? So the last step is to actually check. Okay, is the supplement plus the original, what's that relation to 180? Okay, so it's 145.3. My original over here is 41. Okay, so I take that 145.3, add 41, we get 186.3, which is bigger than 180, right? Because all this whole time was like question mark, we don't know if it's bigger or smaller. And then this last step, when we actually get the number, that's where we can say for sure if it's bigger or smaller. And according to this, since it is bigger, we have one solution, which means there's only one way to draw this triangle, right? So I can connect that and say that's the only way to do that. There's no, double possibility or anything. Okay. So therefore, 3 dots, one solution. Now some of the problems will say how many solutions there are, and at that point you just stop, right? And you can see on the next problem down it says solve. So if it says solve the triangle, that means you find not just the first angle or how many solutions there are, but you find everything. So the directions are important. Alright, lastly, let's see here. Yeah, here's where we're going to, we've gotten a no solution. This middle one was one solution. So this is going to be the example of a 2 solution. The same exact thing will happen, right? Except at the end, this number should be smaller than 180. So if you just go through right now on your own, kind of go through the same exact steps that I just did and just see at the very end that this is going to be a less than, and this number is going to be smaller than 180. Alright, and that's how you know there's 2 solutions. So the 1 solution, 2 solution thing is, basically the same exact steps, except for that one symbol at the very end is different. Nothing else changes. Alright, so if you want to try that on your own, go for it. I'll do it quietly up here if you want to follow along. But it's the same thing. 3. 15. A. B. There. So I did part 1. Part 1. Part 2. Part 3. So you do the supplement plus the original. And you're trying to see its relationship with 180. So we have 138.2 plus the original 30. And clearly we get 168.2, which is this time smaller, right? Because of that symbol right there, that's what lets us know there's two solutions. So in this case, what it means is that we have this possibility for it to be 15, but that means we also have this possibility. That could also be 15 as well, right? And then we can get the two angles. Okay. So the first angle, like this, the first angle would be 41.8. That's the one we found right here. That would be for the acute angle. This will be its supplement. Okay? So this angle on the second triangle will be the 138.2. And then angle C over here will have two different angle C's. So you'll have a 30, 138.2, and then an angle C here. And then you'll have a 30, 41.8, and a different angle C for this two different triangles. And now it doesn't ask on this particular problem to do that, but that's how you get the two answers. The diagrams, definitely helps to write it out. Okay. And if you wanted to calculate the height, you could do the sine of 30 times 20. Let me try that real fast. Sine of 30. Oh yeah, times 20. 10. Yeah. So the height is 10. If you want to go that route, you can say, well, the height ended up being 10, and you can see this value, the A value, is between the height and this value. So for this particular problem back up here, this happens when, the height is 10, our B was 20, the A they gave us was between those two numbers. That's another way of geometrically seeing there's two solutions. So there's two ways of doing this. You can do the geometric way and calculate the height and then compare the sides, or you can do the algebraic way, the more analysis way, where you just see if it's bigger or smaller than 180 degrees. Either way is, well, they're both good. I'd say do both. Draw a picture and confirm. All right. Alright, so I wanted you to practice this. Yeah, okay. Let me change up these numbers. Actually, how much time we got? 528. Actually, no, let's just keep it as is. Let's keep it simple. So, let's try this out. I'll give you a chance to do it on your own. See if it's a no solution, a one solution, or two solution. You don't have to find any of the missing values. Oh no, this one you do have to find the rest of the missing values. So give it a go and see what happens. So this particular one showed up to be greater than 180, so one solution. And now you're not finished though. This one is a solving, so solve for the rest as well. But we got, this is again measure of angle B. That's what this, yeah, measure of angle B is right here. So I got that much right there. So I still have to go through, find out measure of angle A, and find out what A is. So we got two more things to do. Of course, since we have two angles already, you can subtract 75 and subtract 50.6, and that will give you the answer. I think it comes out to 54.4, looks like. Yeah, 54.4. And then lastly, you have to find the missing side, which this is not a right triangle, so you can't use Pythagorean theorem with 4 and 5. It'd be very tempting to say, oh, it's a 3, 4, 5. I see 4 and 5. But it's not a right triangle, so we can't use it. So we got to use law of sines one more time. All right. Use the same values here. So we got sine of 75 over 5. And then instead of doing B and 4, we're going to use our A's, right? Because we now know what this angle is. Sine of 54.6 all over A. There we go. So the measure of the measure of A Okay, find the diagonal with no variable. That goes on top. Got 5 times sine of 54.6. And then the remaining part goes on the bottom. Cross, multiply, and divide. All right. Finish that up. So we have fraction 5 sine 54.6 divided by sine of 75. I got 4.2. 4.2. So sines, sines, everywhere sines. Okay. So your homework is to do A, B, and C. They're on the next page. That's what these are right here. A, B, and C are on the next page. And then you have only 5 problems. 18, 19, 20, 21, 22. 5 problems from the book. Right, so overall relatively short it once you get the hang of it, and you can also the type of calculator that you're using definitely makes a difference. The kind with the fraction button on the screen, you can see the input of it is very clear, non-ambiguous and easy to follow. So I suggest you find something with one of these taller screens. All right.